So the canonical query representation, the use of canonical query is to, one is that you have several seed queries that map to this canonical query, and also the canonical queries are going to act as a semantically related surrogate query for the user query. Okay, so we have this set of we know how to create the set of canonical queries from a document collection. That's the first step. So that's done. Let's move on to the next step. Creating PD-Querysets. So the way we define the plausible deniable query sets with k queries, we need to have a procedure for creating that set. That's the next step. Okay, so the way we do it right now is to create a static linkage between k queries, k canonical queries. So any one of the queries will give you the k minus other cover queries. So it's basically a clustering problem. You have a set of canonical queries and you want to cluster them so that in each cluster there are at least k queries, and also all the k queries are from different topics, and we have the other criteria that all the k queries should be equally plausible. Okay, so this is a clustering problem, and the first thing is to define this dissimilarity function between any point. That's how we cluster the points together. And the dissimilarity function between queries here is based on three measures. One is the Euclidean distance. So we have the criteria that semantically similar queries are together. They are closer in the semantic space. So we are going to use Euclidean distance to capture that. If they are close in the semantic space, probably they are their topic is similar, right? So in a single PD query set, we want to have two queries which are different in their topics. So the Euclidean distance is going to capture that measure. So second thing is the magnitude. The popular queries will have, popular terms will have high frequency in the document collection, which leads to high magnitude in the semantic space. So we are going to use the magnitude for comparing the popularity of queries. The third criteria, we use the neighborhood count. So this is the important one. So we said we want to put equally plausible queries together, right? So how do you measure plausibility in for a query? So here we employ, so we take a query log, a large query log, which consists of all the actual users' queries collected over a period of time. And for each canonical query, we create a hypercube around that semantic the point of in the semantic space, and we compute how many user queries are around or in the neighborhood of this canonical query. So, for example, if you have a document collection with basketball, and I have a query Los Angeles Lakers, and if the semantic space is going to put the Los Angeles Lakers among basketball, that means Los Angeles Lakers is a famous query. It's more plausible query because there are many queries around the space of Los Angeles Lakers. Okay, that's the idea. So we want to use the existing query log to give an indication of whether a canonical query is going to be more plausible or not. Okay, that's a neighborhood count. Okay, so the dissimilarity measure, the score, is a combination of three individual normalized scores. So again, the D1 captures the Euclidean distance. If two canonical queries are apart, that means the topic is different. We are going to make the dissimilarity as 0, or lower dissimilarity. Again, the magnitude and neighborhood count. Here we want to have the, if you look at D3, we want to have similar neighborhood count. In that case, if they are similar, D3 will be 0. That means we have a less dissimilarity if they have a similar neighborhood count. Okay, any questions? Okay, so the clustering algorithm is a simple one we have implemented. It's a simple agglomerative level by level clustering algorithm. So the input to the algorithm is the set of canonical queries, and also k. K is basically the number of queries that you issue in place of a single user query. So to explain it, so the very first level you have all the individual canonical queries, and the next level you pair up the canonical queries which are closer based on the distance dissimilarity function we defined before, and you build up level by level. So this is the kind of a pictorial representation of what's happening here. So in the first level you have all the canonical queries, and in the next level you just find the pair of canonical queries which has the lowest dissimilarity score, and based on the same criteria you build on this. You merge the clusters level by level. Finally it will lead to in this particular case 4 PD-Querysets. So if k is 4 or less than 4, you can stop here, right? Okay, so we know now how to construct a set of canonical queries, and also creating this PD-Queryset for to be issued to the search engine. So next question is, as a user, I want to issue a query. Now, in this system, what happens? So this is the third step. Sorry. Okay. So we know a way to convert the user query vector to the semantic space or the topic space. So the formula we have already seen before. And so basically you find a canonical query which is very similar to the user query. It captures what you want. So that's a query you want to issue to the search engine so that you get what you want, and also you get the anonymity, right? So we use to measure the cosine similarity for finding the best canonical query that you want to issue. So we go through set all the canonical queries and find the canonical query which has the maximum cosine similarity. And next step is to find the PD-Queryset that contains this canonical query. So you want to issue that set of k queries instead of your original user query. So that's the step. Okay, again to illustrate what's happening here, the first step. So user creates user wants to issue a query q, and the q is submitted to the PDS system, and you get set of k queries back. All the k queries are issued to the search engine, and the search engine will reply with the results for all the k queries, not one query, because the search engine at this point doesn't know what is your actual query. So it's going to send you results for all the k queries, right? So again, to remark here, it doesn't affect the business model, the advertisement business model here, because the search engine knows k queries and it can supply the advertisement advertisements for each of the k queries, right? So it's not that it doesn't know what you're doing, and it knows, okay, one of the k queries is your actual user query. So the search engine has the ability to send the advertisements related to each of the k queries. And the user, based on q, the small q, the user has the ability to filter out the results relevant to the original query q. Okay, so again, go back to this whole definition of plausibly deniable search. The deniability is because the canonical query already provides one level of anonymity, right? Because you are going to issue only standard queries, not any constructed form of user query. And also plausibility, it's a more there has to be some kind of human study to see what queries are plausible, but the way we are doing it, based on the fact that a particular query is semantically related to many queries already issued by users from a query log. So the plausibility is also captured here. Okay, so the now question is, so you don't allow the users to form any query, right? Because we are going to issue only standard queries. How good are the canonical queries? Do they fetch what the users want? So that's the most important question.